So last time we started talking about transformation of multiple random variables. So basically, we already finished the transformation of single random variable in chapter 2. Now we are talking about we have function two random variables. So we started this last time, and we gave one example, which is basically the transformation when we have basically y equal to the ratio between two random variables, x1 over x2. And we try to argue that basically in order to find the PDF, we need to find the CDF, and the CDF starts with the fy of y, which is by definition the quality that y is this family specific number, and then we substitute for y as x1 over x2. Now, different functions will have different substitution, and the problem will be totally different. So basically here, for example, you need to integrate the joint PDF of x1, x2 over the region where x1 divided by x2 is different. So basically, here what we did is we draw a line of x1 equal y x2, and then we integrate it over this region, which is basically goes from x equals 0 to x1 equals 0 to y x2, and from x2 equals 0 to x2. Now, if you have different function, then basically the region of integral will be different. So basically, this whole example will be different, and the solution will be totally different if the function given g of x1, x2 is different than x1. So for example, if I give you y equal x1 multiplied by x2, then the region will be different. So basically, you need to define, instead of x1 a line which is x1 equal y x2, you need to define x1 equal y divided by x2. And basically, instead of a line, you have basically an x1 divided by x2 will be like this, and basically you need to integrate over everything, which is big. Okay, so different functions will give you different setup and will give you different solutions. However, the same step is always there. You start with the definition, probability y equal less than y, and then basically integrate. And after that, you need to differentiate. You differentiate what you get here, which is fy, CDF, you differentiate it, you get the PDF. Now today we have another example, and we'll use Eben's rule to basically simplify the solution. Let's simplify, at least to get the solution. Now this rule says the following. If I have a function, g of u, that is an integral of another function, h of x and u, dx. We are integrating here with respect to x. However, the limits of the integral, beta of u and alpha of u, are function of the second. This is typical as what we have seen here. We are integrating here a CDF. The CDF is a function of x1, while the limit is a function of y. Y basically here. So basically, the CDF is a function of y. What is it? CDF here is a function of y. Here, g is a function of u. And you are not integrating with respect to u. However, u here comes into the limits. Similar to the CDF here. The CDF is a function of, here, is a function of u, while u doesn't come in the integral, but it comes in the limit. So basically, this is a general rule that simplifies when you have the CDF, that is an integral expression, and you would like to find the PDF. So basically, this rule says that if I have a function g of u, where u here comes in the limits of an integral, and this function is an integral of h certain function, another function, h of xu dx, then basically to differentiate the g of u with respect to u, where u here comes in the limits of the integral, you need to find h of beta u and u multiplied by the derivative of the first limit with respect to u, minus the same function of alpha u multiplied by the derivative of the second limit, plus the integral of the derivative of the function inside from alpha u to beta. I believe you have seen this somewhere in practice, right? Okay. probably with a different name, although you have seen it. So basically, this is what we have done here. Okay. This is what we have done here. When we integrated, basically what we did is here, we differentiated this. Fy was what? Was double integral, right? Of, sorry, was double integral from 0 to infinity. And integral of from 0 to yx. Right? Of f x1, x2, x1, x2, d x1, x2. Right? Now we can write this in terms of just so we can take this function. Now this is a function of u. الباقي ما هو function of u. It's integral with respect to dx. So this is the function of u. Now call this function as g of u, g of y. Right? Now in order to differentiate now g of y, d of y dy will be the same integral, outside integral, right? From 0 to infinity. However, it will be the derivative of g of y dy. And then dx, right? So simply we need to find what the derivative of dy of y given by this one, using this even. So how to do it? واضح يا شباب ايش اللي نبغى نسويه؟ I gave you the answer, but I did not give you how to do it. So we need to apply the given rule. So now let's focus on dy divided by dy. واضح شو ايش اللي نبغى نسوي؟ We need to find what we have found as this. dfy derivative of the CDF. We found it as this. How did we do it? We find, basically we get the integral. Forget about this. Now we are focusing about here. What is this? What do? We take whatever inside with the limits, right? So we take what? F, x1, x2, evaluated at what? What is the first limit here? Y? Yeah? Y, x2, and then 0, right? Multiplied by the derivative of the first limit. What is the derivative of the first limit? With respect to y, x2, right? Plus, sorry, minus. Minus what? This function is evaluated at what now? The second limit, right? Right? Evaluated at the second limit. What is the second limit? 0 and minus evaluated at the second limit and y. 0, this is 1. Right? And then d, the second limit. This is 0. Right? صح شباب؟ That's the integral from like same limits. X2, the derivative of this. right? Now, I'm missing something else. Y x2, yeah, x2, thank you. Yes, which is the limit, but again the no y x2, it's basically the limit, and then u, which is y. But multiplied by the derivative, which is x2, minus and then here the derivative of now derivative of whatever inside that fxy x2 xy x2 with respect to what dy, and then the x2 dx. Okay. So basically, what is this? And derivative عبارة عن ايش؟ We are differentiating PDF with respect of x1, x2, x1, x2, dy. What is the derivative of this? So basically, because we are differentiating, this is the first step. And what is else? What is this? 0. Because this is 0. And we end up with basically fx1, yx2. So now the PDF of y will be basically the integral from 0 to infinity of this derivative, which is x2 multiplied by fx1, x1, yx1. dx1 dx1 because it's the original g was x1. طيب يعني لا تخيل حنجيب لك الفاينل كذا بس at least you need to understand. I'm citing here another example which is more complicated. But I will go through it very quickly just to illustrate the idea. الفكرة نفسها يا شباب. It's basically الفكرة نفسها. Let me summarize it again. يعني مثلا هنا y looks like this. We are getting the envelope below them. ايش هي معناها x1 square x2 square and then square. This is the envelope of the square of two finite values. Okay? And we assume that we know this. Join PDF. We are interested in the PDF. We go through the same method. طبعا زي ما قلنا شوي حتكون معقدة أكثر لكن it's the same concept. So let me just start with the beginning. FYY, what is this equal to? زي ما قلنا في البداية. It's equal to the probability that y is less than or equal a number, صح? We go and substitute for y. What is the new function? It's under square root x squared plus y x1 squared plus y x2 squared, and the square root is less than or equal a number. Okay? Now, simply you need to find what is this region. This region, we know that it looks like a circle. If y is the radius, then and x1 is the horizontal axis and y is the vertical axis, then anything inside the circle with radius y will be our region integral. صح ولا لا؟ isn't it? So what are we integrating here? We are integrating with respect to x1 we are integrating from minus this. What is this point? It's y squared and the square root y squared minus x2 squared. And this point is y squared minus x2 squared. This is negative, this is positive. So we are integrating over these two with respect to x1. What about with respect to x2? What are we integrating here? We are integrating from minus y to 1. So this whole function and this whole function will look like our y and x2. So I of y and x2 will look like this integral. تعالوا نطبق نفس اللي سويناه قبل شوي. So what do we have here? We have the CDF. We want to find the PDF. What is the PDF? Well, it's the derivative of the CDF, right? So it's the derivative of what? d y of what? Of the integral from minus y to y of I of y, sorry, y and x2. d x2. So we have here what? We have a function that is the function of y and x2, and we are differentiating with respect to y. So let's just say limits here with respect to y. Okay. Let's see how to do it. Well, the vision of integral is it clear with everybody? How do you find it? So. طيب انت عندك الان you are integrating اول شيء انت you can start with x1 or x2. الان if we start with x1 we assume that y is fixed. So what is this point? Basically, okay. هذا اللاين is the equation of x1 square plus x2 square equals 1. صح؟ هذا الكيرف هذا اللاين. لا هذا كل اللاين. This is the circle that is equal to that basic satisfies. أي نقطة هنا تأخذها x square plus y square x square plus y plus x2 square will give you this. ايوه فالآن إذا أنت الآن تبغى تاخذ طيب from fixing x2 then what is y equal to? So the x1 equal to what? It's equal to إذا تفتح هذه إيش يصير؟ x1 squared plus x2 squared equals y squared. صح؟ So basically x1 equals what? x1 squared equals what? y squared minus x2 squared. صح? So x1 goes from minus the square root of this to plus the square root of this. خلاص؟ الآن we know what x1 is. Then what is x2 goes from where to where? It goes from minus 1 to 1. So now we have the CDF as an integral of a function of y, and we have the integral the limits are also a function of y, and we want to differentiate with respect to this thing. So we are taking a derivative of a function where the symbol that we are differentiating with respect comes in the limits of the integral. So here we need to apply the limits. So what do we have here? Again, we have y equal I u x2 equals this function. Now, what is Leibniz says? If I have a function u such that u comes in the limits of another function, that the integral of another function that is a function of x and u, then the derivative of this function will be the same function I am integrating evaluated at the first limit, multiplied by the derivative of the first limit, minus the same function evaluated at the second limit, multiplied by the derivative of the second limit, plus the integral of the derivative of the function between the same limits. So basically الفكرة كلها كالتالي. In order to differentiate this function g of u, I take the first function I evaluated at the first limit, multiplied by the derivative of the first limit, minus the function evaluated at the second limit, multiplied by the derivative of the second limit with respect to u, minus the same integral but with respect to the derivative of which. Now let's apply this here. What do we have here? We have fy of y equals the integral from y to minus y of this function. Right? So what do we do? In order to differentiate this, I take the same function evaluated at the first limit, صح? So it will be I of y and في غلطة. هذه y. This is y. Same step. So it's I of y and 1, right? Multiplied by the derivative of the first limit. What is the first limit? Y. Derivative of y with respect to y is what? 1. So basically, it's the derivative of y with respect to y, which is 1. Minus this function evaluated at the second limit, which is minus y. So it's I of minus y. Multiplied by the derivative of the second limit with respect to y, which is d minus y, which is minus 1. Multiplied by the derivative of this thing, the function as ui, so, however, integrated from in the same limits, minus y to 1. So now, what is I, y? Look at this is I. This is I function of y and x2. What is I, y? Evaluated at y. Yeah, it's basically integration. If I put this as y, then what will be this? The limit. Y squared minus y squared, which is 0, and y squared minus y squared is 0. So I'm integrating any function, it doesn't matter what the function is, from 0 to 0. What do you get? 0. So basically, this is the first thing. This is 0. This is 0. The same thing here. Y minus y. Y minus y. Again, if I put y on the minus y, هيكون x2 squared is minus y squared, which is 1. So again, y squared minus y squared, again 0, 0. So I have another function which is 0. So the only remaining function that is I have to evaluate is the integral from minus y to y of the derivative of this. Okay. Now I apply this. Now again, what do I have here? Again, what is this? So what do I have here? I have a function. I want to find this, right? In order to make the integral, I need to find this. So, but what is this? It's the integral. هذا نفسه is an integral. So I can apply Euclid's rule again here, صح? Is it? So how to find this? Apply Euclid's rule. What is this? The function هذه evaluated at. This is by itself. I, y, x2 is a function of y and x2, صح? And I want to differentiate this function with respect to y. However, y comes in the limit. So that's the المشكلة again مرة ثانية. So what do? It's the function inside, huh? Right? Evaluated at what? Evaluated at what? The first limit. What is the first limit? Square root y squared minus x2 squared, right? And x2, right? Multiplied by the derivative of this, d square root of y squared minus x2 squared, and d what? dy, right? صح? Minus the same function, however, evaluated where الآن? The second limit. What is the second limit? Minus y squared minus x2 squared. Again, x2. D minus y squared minus x2 squared. D1. Plus the last one, which is the integral of the derivative, right? It's the integral of the same thing. Minus of d f x1, x2, right? x1, x2, dy. But what is this again? It's 0. Because it's right? So what do I have here? I have the PDF evaluated at this, multiplied by the derivative, minus the PDF evaluated at this, multiplied by the derivative. It's the PDF evaluated at y minus y squared minus x2 squared under the derivative, multiplied by the derivative of this, which is this thing, very derivative. Multiplied by the PDF again evaluated at minus طبعا هنا في minus لكن when you differentiate this it will give you a plus. You get this. So the PDF of y ايش كانت هي؟ The integral of this for minus y to y. It's the integral of this. It's a complicated function. I get اصلا مشكلة الموضوع كله complicated من هو. Oh, you get this. Well, good luck. You need to do it numerically. I hope you get it out. But you don't expect it complicated examples like this in the exam. However, you need to understand the concept. The steps at least اللي شرحناها. Just to summarize before I go to another place. The steps are as follows. You need to find the CDF, and the CDFs comes with the definition. Now you replace the definition with the function, and then find from this function the region of integral, and you need to integrate the joint PDF over this region. Now how to do it? It's up to you. Use this rule, use another rule. Might be simple, might be complicated. That's a point. واضح؟ أي سؤال شباب؟ طيب, I hope that you do some practice here. At least regenerate these two examples, at least so that it sticks in your mind. understand? يعني هذا هو الانتجرال الاصلي. الانتجرال y basically was this integral dx. So it's the same. It's the same integral, but you الآخر term عبارة عن integral, the same integral, the same limits, the same thing, but the function dy. أي سؤال؟ هذا؟ لا هذا هو هذا الانتجرال صار زيرو. هذا الانتجرال to find what is this. However, the PDF is another integral from minus y to y dx2 of this. هذا الآن لقيناه. So, please try to regenerate these two examples. Go through them by hand so that at least you understand what I have done. Again, you don't expect such complicated integrals or regions of integrals. You are not examining you on calculus here, but at least you need to know how to do it. طيب, الآن let's have the last topic, which is basically related to transformation of multiple random variables into multiple random variables. So here we have multiple random variables, x1, x2, x3, x4 in general. You will stick only to two random variables in the examples and so on. However, the concept is just given for many random variables, and you have a transformation, okay? And then you have a new set of random variables. So here we have, in general, n random variables, okay? So basically, you have certain set of random variables. You need to transfer it to another set of random variables. Now, what to do? So I will not go through what is the solution. We'll give you the solution. First of all, so basically here, first of all, if we put n equal 1, then we get what? Single random variable transformation. N equal 1 means what? Y1 equals t1, which is one function of n random variables. Okay? So if I put n equal 1, we get the previous case, where we have only one function. Now, we assume that ti's are single valued, continuous function. Single valued means what? Things that they don't go up and down. They are not cosine, they are not x squared. They are single valued. It's either numerically decreasing or numerically decreasing. So this is the first thing. Ti, every function of these is single valued. With partial continuous partial derivatives everywhere. So basically, there's no discontinuity in the function. Such that xj equals t inverse tj of this act. This is the inverse of the inverse operation. Then in this case, we define what we call the Jacobian. The Jacobian is the determinant of this matrix. Partial derivative of t1. T1 is شباب ايش؟ a function that takes, so basically we have here what? X1, X2, X3. Here we have Y1, first of all, equals T1 of X1, X2, okay? Well, Y2 is what? It's 2T, 2T2, T, yeah, of X1, okay? Y3 is T3 of X1, X2, rather. So when we say here the Jacobian, which is the derivative of T1 with respect to inverse of T1 with respect to Y1, and so on. So here we have T1 with respect to Y1, T2 with respect to Y2, and so on until Tn with respect to Y1. And we go on the column wise, T1 with respect to Yn, Y2, Y3, Yn, until we get Tn with respect to Y2. Then the PDF of the outputs, which is Y1, Y2, the joint PDF, will be equal to the joint PDF of the inputs, however evaluated at X1 equals the inverse function T1, X2 equals the inverse function T2, and so on, multiplied by the determinant, and it's a determinant, صح? Determinant of the matrix J. هي ايش يسموها؟ جوكيبيان. ليش يسموها جوكيبيان ماتريكس؟ ايش رايكم شباب؟ ليش يسموها جوكيبيان؟ Yaqub. Good. Okay, so basically, Jacobian matrix is the behind the SML or Jolly. He differentiated or he derived all this. Okay, so basically, let me take it now to a simple example. And we'll take an example of linear example. So here, y1 equals t1, x1 of x2. However, this is a linear operation. It's ax1 plus b. Okay? So we have here two random variables only. We will stick again to our examples into two random variables. We get the inner picture, but you are responsible for two random variables. So here, what do we have here? Y1 is a new random variable that is function of two random variables, x1 and x2. How is this function written? As an example, it's ax1 plus b. It might be another thing. However, they have to be one single value. It's a single value. You didn't have x squared, you didn't have cosine, you don't have equal exponential of x1 plus minus 1 over x2, whatever function. Okay? And y2, in this particular example, it's a function, t2. However, it's a function cx1 plus cx2. So if we write in terms of matrix, y1, y2 will be a vector, which is a function of the vector x1, x2. However, how is this function equal to look like? The function y1 عبارة عن t1 of x1, x2. So this is y1. Y1 is the function t1, while y2 is the function t2. But what is t1? T1 is x1, ax1 plus bx2. And t2 is dx1 plus cx2. So, how to write this in terms of a matrix multiplied by a vector, x1, x2? It's ax1 plus bx2, so I can write, and then the second one is cx1 plus dx2. So I can write this as a matrix multiplied by the vector x1, x2. We call this as the transformation matrix. الماتريكس اللي تاخذنا من x1 الى x الى y الى من x الى y. Okay? Right. So what do I need to do الآن? I need to find this Jacobian. What is this Jacobian? عبارة عن partial derivative of t1 inverse with respect to y1 and so on. So I need to find the inverse functions. What is the inverse function? T1 inverse is x1 when expressed in terms of y1, y2. And I'm going to ask about y1 is T1 in terms of x1, x2. Then T1 inverse is x1 in terms of y1, y2. How to find x1? How to find x1? And I have two equations here. I have y1 equals ax1 plus bx2, y2 equals cx1 plus dx2. How to find x1 in terms of y1, y2? I have two equations with two unknowns, right? I need x1. What is x1? Substitute what? If I subtract these two equations, what do I get? Well, if I add them, what do I get? Or I multiply this with d, and I need to get rid of x2, right? So basically, if I multiply this with d and multiply this with b, and then I subtract, what do I get? I get dy1 equals dax1 plus 0, sorry, plus whatever, dbx2. Well, I get what here? When I multiply by b here and I subtract, what do I get? dy2 equal bcx1 plus bdx2. Now, if I subtract, I get these two out. When I get them out, what do I get? I get here. I get what? Yeah. So basically, I get here dy1 minus by2 equals x1 multiplied by dA minus bc. So I divide by this term, I get basically dy1 minus by2 divided by this term اللي تو نتكلم عنه اللي هو ad minus bc. This gives me x1. Now, simple process of solving two equations with two unknowns. Now, what about x2? I do the same thing, but I eliminate what? x1. So I multiply by d, I multiply by a, and then I subtract them. I get basically x2 as minus cy1 plus y2 divided by the same number, the same thing. So if I write them in terms of matrix, x1, y1, x1, x2, so they will be T inverse of y1, y2, which will look like x1 here, x2, which is T2 inverse, which is basically, لو تلاحظوا هذا common factor. So I can write them in terms of y1 and y2. y1 will be multiplied by d, right? And minus b, and divide by this number. Right. And y2 will be multiplied by minus c here, and a, and divide by this number. So now I can write x in terms of y. If I عندي أنا y in terms of x, I can have x in terms of y. What is this, شباب؟ مقارنة بهذه. What we did basically is we found احنا عندنا x as a vector equals certain transformation نسميها ايش نسميها g, okay, multiplied by sorry y as a vector. This is الشباب اللي أخذ لي الجبر أعتقد معظمكم أخذوا. Y equals gx صح؟ So x here equals g inverse y. طبعا ايش الشرط هنا لازم يكون g inverse exists, okay? Which means that y, sorry, g should be full line. ايش يعني full line؟ ما في the two equations are independent. ما في equation لها علاقة بالثانية. Now the Jacobian is simply the determinant. The Jacobian is simply this thing. This is together. هذه اسمها j. So basically, j equals g. Now I need to find the determinant of j. Have a determinant of j. You know how to find the determinant. 2 by 2. This by this, right? This minus. And these two multiplication minus these two. multiplication, I get this. So now the PDF of y equals the PDF of x multiplied by the determinant of 2. But what is the PDF of x evaluated at x1? What is x1? Here. This is x1. And x2 is this. So the PDF of y will be equal to the PDF of x, whatever that PDF, evaluated at these two numbers and divided by x. هذا أسهل شوي صح؟ نفس الشيء شباب كله تصميمية تصميمية نفس الشيء. تفضل.
ليش ما كان absolute value AD minus determinant?
Yeah, because it's a determinant. It's like يعني هي القانون كان absolute value of the determinant. Absolute value. So you need to take the absolute value. Okay. So a linear transformation of random variables is extremely common. It's in it has some. What if, as an electrical engineer, you get certain signals, you need to process them, and then you get new signals. هذه طريقة السيجنال الكنترول حتى. So basically, big or communication, big part of the electrical engineering is related to this concept. You get certain, you get certain signals, you process them, you get certain signals. So you need to know what this transformation will do to your random variables at the input, such that you know what is the distribution of the random values at the output. So this is a common problem in electrical engineering, many system-wise kind of topics. Okay. So الآن if I give you, زي ما قلنا we'll stick to 2 by 2. So if I give you another set of functions, بدل السمبل هذول ax1 plus bx2, if I give you another ones, like for example, y equal exponential of x1 plus 1 over x2. And y2 equals x1 plus 5 log x2. Nothing. What you need to do is, first of all, start them in terms of matrix. If you are able to write log x, you cannot write it. However, you need to find the ends. You need to find x in terms of y1, y2. هنا كان عندنا 2 linear equations we solve them. لكن هنا مو شرط. هنا ممكن يطلع لك very complicated. And then, once you find them, you need to take the partial derivative of every one of these inverse functions, find the determinant, and then try to be. Right? The example اللي أعطيتكم إياه, the inverse function will be complicated. لأنه هيكون عندك exponential وهنا 1 over x to how to find them. يعني basically when you look these. However, the general concept is like this. Okay. Now, a direct application of this concept is the linear transformation of Gaussian random values. So when you have jointly Gaussian random values and you apply the same linear transformation. احنا أكثر شيء مهتمين فيه في الكورس هذا is the linear transformation. So this concept will mostly apply to linear transformation. But in general, it's applicable to any transformation. So what do we have here? We have jointly Gaussian random variables. And we are putting n of them. So n, however, our examples will be only focused on 2 by 2. So y1 will be equal to certain linear transformation of all of them. Y2 will be linear transformation of all of them, and so on. So basically, we have a transformation matrix A11, A12, blah blah blah, A1n, and so on. And y as a vector will look like y. Will look like t multiplied by y as a vector will be t multiplied by x as a vector. واضح؟ linear transformation زي ما سوينا قبل شوي. Then we know y. What do we know about y? We know y mean, and we know the covariance matrix of y. Now what we are interested in, I'm sorry. What we know is about x is its mean and correlation, the covariance matrix. We need to find Y in mean and the covariance matrix. Then I have the jointly Gaussian United values are specified by only the mean and. So these are the unknown, these are known. These are the unknowns. So without derivation, what I say, Y will be a transformation matrix multiplied by X. In my writing, I put this as a vector. لما أحط تحت معناها vector. هنا في الكتاب عندكم يستخدم هذا النوتيشن. Y means Y vector. Okay? X بين قوسين بين two brackets معناها X vector. بعض الكتب تستخدم underscore as a vector. لكن الكتاب ما يستخدم. So all these brackets means vectors, okay? Or matrix. So T here is a matrix. T is an n by n matrix. All right. So now Y is a matrix, transformation matrix multiplied by X. Then X is the inverse transformation matrix multiplied by Y. Okay. And طبعا you know that this Y T should be non-singular. Again, we are interested in the average of Y and the covariance of Y. طبعا هنا في شرح كثير. I will not go through it. You can go through it. What I'm interested in is the following. The Yj, the mean of the jth element will be T multiplied by the expected value of X. And the covariance matrix of Y will be transformation matrix multiplied by the covariance matrix of X multiplied by the transformation matrix transpose. هذه معناها transpose. Okay?
Which key of X do you have many values?
لا هذه فيها خطأ. هذه فيها خطأ. This is basically expected value. معلش هذه اعتبروها خطأ. هذا هو. This should be. So these are the two rules. خلوها ارجع اسوي يعني باختصار النتيجة is the mean of Y equals transformation multiplied by the mean of X. The covariance matrix of Y equals transformation matrix multiplied by the covariance matrix of X multiplied by transformation matrix transpose. في derivation that will not go through. It's using the same concept here. Okay. ناخذ example makes it simple. Guys, really attend this. Right, next time we continue the example. So please read the material that we just covered. Okay, so that you can next time please more fresh about it. Okay. Thank you very much. We'll see you inshallah next time.